everyone. This is Hossein Mokhtarzadeh, and I would like to talk about OpenSim workflow on the Google Colab tree, how we installed it and how we gonna compare it. So we call this OpenColab or OpenSim in Google Colab. Let's just get into that. So OpenColab or an OpenSim. So installing them via Conda, importing the files, and inverse problem, we're gonna solve them, and you'll see how it works. So first, as I said, let's install. We've got a lot of tutorials. Please feel free to watch them. Uh, from scaling and why we use these and how we can use it, how you can actually write Python codes on Google Colab if you're not familiar with this. Uh, and then you'll see how easy it is basically to use it. So as I said, OpenColab is OpenSim in Google Colab. This is the project we are pursuing, and I would like to thank my co-authors as well. Here's what we're going to cover today. Quickly installing OpenSim via Conda, import irrelevant files. You know that regardless of where your platform is, you need to bring the files, model, set of files, like XML files, etc. And then doing the workflow in GUI, I'll show you quickly, and same workflow in OpenColab that we have created. And it's freely available, and then comparison between the two and see these differences, if there is any differences between these two interfaces. Okay. If you've watched our other tutorials, you know that it's quite easy to install OpenSim now on Google Colab. So if you've done it for you, you just need this block of code, and that's it. Especially this line of code basically installs it for you in like 7 minutes or so. When you do it, you can see here OpenSim, there's quite a lot of things we install so that we need to like create graphs, figures and things like that. So OpenColab, the very latest one, 4.3 is installed. It's like 1 GB. Pretty much all the libraries and dependencies are here. If you run it successfully, you'll see this at the end of that block. I'll show you now. So around 7 minutes. All packages, OpenSim, installed there on the cloud. So it's a virtual machine, nothing on your computer. That's the beauty of it. We don't want to install anything on your computer at this stage or even later. It's just everything on the web. Then we import the relevant data. We just use GitHub to store it. It's up to you. You can even download it. You can upload your own data. I'll show you quickly, but here we found it easier to just git clone all the files from GitHub, or if we made any changes, we store it in our GitHub and then bring it here. Okay, or copy them here basically. So here's the workflow. I'm sure you're familiar with this. You collect data so this is because it's based on my PhD. This is landing trial. This is gaining trial, any motion, human motion with the markers. So recently we did even markers. You can have variables and all sort of other type of, even videos, But then, so it's again, we used to have like icon data, so it doesn't matter. So let's imagine we have marker data as the static, like someone static trial and scale it. So we get generic model. So it's going to be scaled. In the meantime, we have dynamic motion or trials. That would be kinematic part of it you get. So in the same time, force plates are used. So again, you can get joint torques, and then you distribute it for the muscles, and you just adjust the model as well because the dynamic is not consistent. So then because we are not modeling everything, so OpenSim static optimization, CMC, or so many other algorithms you can use, optimization, so that you can predict muscle for this is a inverse problem, as you know, or neural excitation. The other way around is the forward one. So you're familiar with it. We showed in one tutorial about the scaling, and now we're going to go the rest of it. Okay, so this is that video, scaling in OpenSim versus Google Colab. Please feel free to watch this one. This is the link to that video. Okay, and this is the video. And here is basically what we did in the GUI. I'll show you quickly now as well. And here's the workflow, just a few lines of codes, from OpenSim and install it. So you bring this, you import a scale tool, you import the inverse kinematic and dynamic. RA, and CMC, and that's it. You basically run all these XML files, all the setup files, okay, on the cloud. Again, nothing on your computer. You can share it. You can work together like a Google Doc with the collaborators. That's the beauty of this. Please watch one of our videos about all these details, the possibilities or case studies that you can do. So that is what we would love to achieve. So here is the demo. Let's just get into that first. The demo on the OpenSim site. Okay, open your OpenSim, the latest version here, for instance. Okay, so I'll start over. So close everything. Um, say discard. Don't save anything. Do you want to save? No. Okay, so from scratch. So you open. This is OpenSim 4.3, just recently released. So I'm going to open the model. So let's say this model 2352. Okay, 23 degrees of freedom, 54 muscle fascicles. Okay, here it is. Then you have the model, the body's joints, forces, which are basically now here muscles, you can have other actuators, etc. Okay, here we're gonna start from this. These are the procedures that we want to do: scaling, your schematic, dynamic, state position, RA, and capital CMC. You can do others as well, but we will just stick to these ones. Okay. So if you do a scaling and then load and then find the setup file or scale here, okay, and open, and everything will be set up for you. It's easy to weight, even the scales, scale factors for different part of the body, the pose weights, etc. Okay, and that's it. You simply run it. You see how easy it is. OpenColab, pretty much similar idea. That's done. Okay, and then we come up with we get what the total square is, and the static pose is here. Okay, done. Then we go ahead and do what we call it, the inverse kinematic. So in your inverse kinematic, same idea, load it. You can make changes to them as well. So where am I? Here we find setup file or IK. Get into them, try to look into the XML files, and you'll see more about them and the weights here, and as simple as possible. There's a lot behind it, of course. If you collect data, there's a lot of things to do manually. There are people working to make even that part automated. We have done to some extent, but it will be eventually. But at this stage, it's not that easy that I show you here. Okay. But anyway, run, and you can see the inverse kinematic data is being generated, which means that the markers here and the markers, virtual one and the actual ones, are being minimized. Okay, the distances here is the IK result. You can save it, And then the next one would be inverse dynamic, which is the joint torques. As you know, let's see if we have inverse dynamic one. Probably inverse dynamic is not here, okay? But you can do an analysis, inverse dynamic here, actually. So when you do it, everything is set up for you, the file GRF, because you need the ground reaction force here. Not always, but there are methods that you actually can ignore that just from the kinematic, you get it. But anyway, so run it. You just do this quite fast, Where am I? Here we go. Here's done, and the inverse kinematic result is written, and here's the inverse kinematic result. Same, okay? The same kinematic, okay. And then we go ahead do the static optimization, right? Again, loading it. So where is SO? Static optimization, if you can find it. Scaling, task, control. Probably static optimization is not here, I guess. Well, anyway, we'll do the CMC, which is somehow similar. Static optimization, a little bit of, like a forward dynamic in it as well. But this one will take time. But it's a set of all content analysis are then requests. Okay, let's just close it because we just chose static optimization while we used CMC. So let's do that. Let's load this. Where am I? Here's CMC. So you can add this an analysis and then add this static optimization. But let's do this for now. And then before CMC is better to do what you may call it RA result. So let's do that one. RA. Where is it? RA. Forward RA here. So it's just adjusting the model, for consistency, dynamic consistency, and everything is there, perfect, and run. Again, they're not that easy that I'm showing you. So this one would be a bit time consuming. Not, it's quite fast because it's still dynamic, inverse dynamic. So it creates, the new a little bit of changes in the kinematic and what you may call it, the whole consistency of the whole model. Okay. Okay. So here you go. The RA is there. So stop this one for now. Let's do finally CMC. So load it, CMC setup, done. And everything is there. So you remember this was red, but now it's reading the RA, the kinematic data, okay? And the results will be written in the results section. This will take possibly time, quite some time. So while this is being done, so it's basically, you can see it's quite some time because it involves inverse stack optimization and forward dynamics. So it takes time. So it's Windows going forward. Anyway, so what we're going to do now, so where were we? Here we did this in the GUI, so you can do it. What we have done this, collected this data and put it into our GitHub, and then from there into Google Colab. Okay, let me say Google Colab. I mean here. Okay, this is our Google Colab platform. Not our problem. There's a Google platform that we have built OpenSim on it, and you can see pretty much all the details that we have done on the GUI. And the GUI here, you can do it. Okay, so how to use it, please watch these things if you have time, but you don't have to. Basically, when you load this one, how you load it, you have shown you before. You can actually start over and you just go to this website like collab.research.google.com, enter. Imagine let's just leave everything, okay, and try to upload the file that we have given you. So that's the file, this OpenColab, okay. I'll bring it here so that I can, yep, just drag and drop. That's it. Okay. It's going to load everything. I usually prefer to remove any virtual machine from here. Okay, these are managed sessions. Okay. If there's any virtual machine here, you can see there's a virtual machine already there. So terminate it. Because we just submitted it. So it's 2 minutes there. So it means the previous one is still there. Okay. And even, yeah, that's all done. So clean and clear. And even if you have done something, you can actually clear our output. So there's no output there as well. Okay. Then you can do the connect, doesn't matter, or you can just go, because everything is done for you. So you can see here what is scripting, comparison between different APIs, and run the following. So these are what we are saying in terms of how to write. It's very simple. In 1 minute, you can set it up as I showed you. Install OpenSim. That's it. That's the code, the piece of code that you can actually use to install OpenSim here in 7 minutes or less. That's it. These are all the codes. Okay. Not everything is about OpenSim, but as I said, it's installed everything that you need to run on this package on this notebook. Okay. So for that, I'll just run all. Let it run all. You'll see, and I'll show you where things are happening. Okay. So it's initializing, connected. That's it. So connected to the virtual machine, and that's it. You go ahead and read what's going on. This is our OpenColab, what we are, the framework we have developed, collecting the data. OpenSim, similar to what OpenSim does. OpenSim does all the workflow, that the inverse problem. Even the forward one, you can do that. Then from here, the results that I showed you, we bring it into GitHub. So we have that. In the meantime, we bring the raw data into Colab. I'll show you here. And at the same time, OpenSim is installed via on the cloud, and then bring it into here. So basically, here this is being installed. As you can see, this is being installed. The OpenSim. Okay, that's as easy as possible. And then that's it. When we have the results, we can do visualization, also machine learning, or whatever you would like to do again here. And then you can actually comment here, share with your colleagues, and imagine you are seen in a meeting and you can collaboratively work on something. Okay, what I would love to see is simplicity. What I would love to see is not digging into like, oh, why this setup doesn't work, what that configuration doesn't work. I want everyone to be able to, because it's like more than 10 years I'm doing this, is always have difficulty to share things with other people. But now we have an ability to. It's Python, of course, if you're a MATLAB user, a little bit not challenging. It's very simple. You can shift quickly. But again, this is the Python writing Python on the web. It's really cool. So anyhow, this is being done. Yeah, there's more information, how to run it, the scripting, comparison, as I said, running as it's being done. You can see here's basically running the OpenColab, the latest version, like 1 gigabyte or so. And then importing, as I said, importing the data sets. If you're interested, you can just click on this show and show you where we are importing things. Double click here, just closes that. This shows it's running. You see here, you could have clicked every single cell, but here basically you see there's 2 minutes is being run. Okay, and then yeah, this one is being run. This is, and they are all in the queue. Okay, you can see it's just quite large. That's why it takes about 7 minutes. Okay, it's done. Then you can use it, for hours. Anyhow, then some plotting stuff, plotting functions. You can see this is what we have written so that we can plot later easily. You'll see what I mean. Here you can deal with your CTD file. We don't want to go through this one, but we can actually expand upon this later on. If you want to look at the codes, have a look. Scale. This is the part I showed you in what we call it in the GUI. Here we're doing it on the Colab or Google Colab, or we call it OpenColab. Same idea. Just import and run. That's it. And here, for instance, let's see that. Yeah, this part is just simple, like how the model works and what it includes, like joints, bodies, etc. I can have a look. This is optional, okay, for you guys. This is what I'm talking about in terms of the inverse problem. Okay, and have a look. Here, scaling. Okay, this comes from the OpenSim website and how the scaling works and how scaling generic model is being scaled. And here's the code. You can actually manipulate yourself if you like. Okay, and then after that we do the validation. We want to know if this is exactly what the GUI shows. Okay, we just compare it with the GUI. And then inverse kinematics, similar idea. We do the little bit of like how this involves things, and then here's the code. You can double click on it, and then we bring data from the Colab here, the code here generated by OpenSim GUI. We collect data here. We actually read the data. So these are just bringing them and read the data, and then trying to what you may call it to match the timing, etc. And then you can actually change a little bit of timing as well, which gate cycle. These are just gate cycle, initial contact, and one gate cycle, and then what we call it, then the results. Okay, then you'll see the results as we go. Inverse dynamics, similar idea. Show the codes, scripts to perform it, and the plotting here, same ideas goes. RA, very similar. Static optimization, you can see here. If you want to check any of the codes, that's the beauty of it. We share everything, so you can reproduce every single part of this yourself, every single part of the code, and as well as the graphs and figures in the paper. That's what I would love to see in reproducing things. Here's the code. Okay, that's it. And yeah, how we collect data from OpenSim GUI and Colab, and this is the CMC. CMC usually takes time, as I said here. Even here, it takes time. I think it's done here probably. Yep, it seems it's done. Well done. You can plot things, you know that. You can plot the results. I think it's the page. Okay, let's say load from 5. The result CMC, okay, like actual force, and then say, okay, I want to check these muscle forces, okay, and then versus time. You do this and then go ahead and check it in Google Colab. We've done this for you for major muscles, and you'll see how close they are, okay? They pretty much match, They should. Just a little bit differences might be because if this is Python based and that could be C++, okay, doesn't matter. It's very, very, matching perfectly, quite perfectly. Yeah, and then finally we save everything for you, like in the still the files are not here because we are installing. I think the installation should be done by now. No, it's still the other things like NumPy because we use them later on. Okay, I think OpenSim is done for by now. Okay, so let's go back and see what is happening next. So I showed you both the GUI and then validation, how the codes go, OpenColab and the GUI, we collect data. And here's the results that you'll also see in the Colab as well when you run it after like 20-30 minutes. Okay, so I would suggest that you do first that and then come back and read the paper and even watch this one first, and then you'll see how easy it is basically to run everything. So these are major muscles like lower limb joints, inverse kinematic, inverse dynamic, RA results. What we call it, there are four graphs on top of each other, like from GUI as well as the OpenSim. Okay, OpenColab basically. Okay, that is neat. And then the same thing for CMC results. Okay, so you'll see the muscles like hamstring, quad, major muscles we just brought, and you see that GUI as well as the OpenColab, how they match. I think these are like left and right legs. Yeah, left and right, and one gate cycle, and like hamstring muscle forces using GUI versus OpenColab. Okay, so hope you enjoyed that. OpenSim GUI showed that the results of the collab and the GUI perfectly match. Okay, hope you enjoyed that. Let's see if the place the installation done. Yes, you see the installation done in like 7 minutes or so. Okay, the importation is done. Then you tick here, importation done, cloning all you need, and then if you do this, you'll see all the results, all the folders. As I said, later, if you really don't trust these or don't trust them, you can actually upload your own. Although it is the encrypting is strong from Google, but still you can actually click and bring your own files. Okay, here the XML files or whatever files you have. Okay, but you probably need to manipulate the code so that it matches with your own data. It's like your own computer, but everything is here. Every single thing that you need. The coding and the plotting is there, and the C30 file, a little bit of manipulation. And here's the scaling, etc. is happening. So let's have a look, see what's happening. The body, the body muscles, etc. And let's keep going. These are done, perfect. And yeah, the validation done as well. Okay, you can see here that matches with the GUI. The inverse kinematic, I believe this is done by now. Yeah, tick and tick. The results are being read. Perfect. And here's the result. You see, this is what I meant. IK results like a knee angle, right from Colab, left from Colab, GUI, etc. And the results also written here for like a high quality SVG files here for you. It's a dynamic version, dynamic plotting, so you can actually manipulate them, run here, run there, bring them back. Okay. See, and you can even like produce what we call like copy, download, etc. Hope you enjoy that. Here you see the matching, perfectly matching, and here's the actual results. We just show them roughly, but here the actual result that you see in the paper. We just made them the color change. That's the difference. Okay, and right foot strike. This is it. I think image dynamic is done as well. Yep, here you go. Image dynamic and rest. All right. I believe inverse RA should be done by now. Yep, we can see here done. SO should be done by now. But state computation is buying time. It should be quite fast, state computation. But then for CMC, be mindful that it takes time, like what you noticed in the given in the GUI. Okay. Okay. So thank you very much. Hope you enjoyed that.